In today's class, let us start with the last two applications of an Opamp, which are Opamp as an integrator and Opamp as differentiator. So what basically is a differentiator? A differentiator circuit is the one that produces a constant output voltage for a steadily changing input voltage, whereas an integrator circuit is the one that produces the steadily changing output voltage for a constant input voltage. About this we shall study in today's class. So this is the circuit diagram for Opamp as an integrator. When you look at the circuit, you will understand that every other part is same except the feedback. The feedback was considered as the resistance in the previous cases, but in integrator the feedback circuit will be having, or the feedback will be considered using the capacitance. So in the case of differentiator, both of these will be interchanged. So this is the hint that I am giving to you about the circuit. In an integrator, in the feedback there will be a capacitance, and in the differentiator at the input there will be a capacitance. So now let us begin. We know that already the non-inverting terminal is being given to ground. That is why the value for V2 is equal to 0. So if value of V2 is equal to 0, let us now try to analyze what the value for V1 is. We know that because of the high input impedance, the current will be flowing in this particular way. That is why it is I1 is equal to IF. If this is the case, and according to the virtual ground, we know that V1 is equal to V2 is equal to 0. Now let us try to analyze what is the value for I1. I1 is situated between two voltages. The first one is Vi, second is V1. That is why the answer I1 is equal to Vi minus V1 upon R1. But we know the value for V1. The answer for V1 is 0. That is why I1 is equal to Vi upon R1. It is shown here. Now let us try to analyze what is the value for IF. Finding IF is not here with respect to the Ohm's law, because Ohm's law holds true only when it is current, voltage and resistance involved, but in this particular case there is no resistance here, it is capacitance. Now let us see where is IF flowing. IF is again situated between the two voltage levels. One is V1 and the second is V0. So now what is IF is equal to? IF has to be found at the capacitance here. That is why C into rate of change of V1 minus V0, which means it is rate of change of both these voltages. So IF is equal to C into d upon dt of V1 minus V0. What is the value for V1? The answer for V1 is 0. That is why IF is equal to C into d upon dt of minus V0. After taking this minus outside, we get the answer for IF as minus of C into dV0 upon dt. So these two values are supposed to be equalized now according to the formula of I1 is equal to IF. So when we substitute both the equations, that is Vi upon R1 is equal to minus C into d upon dt of V0, we will now try to form it in this way that we will write the equation for dV0 upon dt. If we write the equation for dV0 upon dt, that minus C comes on the other side. If it is minus C coming on the other side, we will be having the answer d upon dt of V0 is equal to minus of 1 upon RC into Vi. Instead of writing this R1, I will write it as R only, because however there is only one resistance. Even if I write R1 or R, both of them are same, as there is only one resistance involved. So now let us try to integrate, which means if I try to send this differentiation on the other side, what later happens? We will get the value V0 is equal to minus 1 upon RC is constant of integration of Vi. Integration runs from 0 to maximum of t, and this is nothing but the integration constant. So if the initial voltage on the capacitor at t is equal to 0 is 0, then V0 of 0 is also 0, which means now if I write the equation for V0, V0 is equal to minus 1 upon RC is the constant, and we can understand one particular factor, that output voltage is nothing but the integration of input voltage. So what is the output voltage here? Output voltage happens to be the integration of input voltage. Hence we call it an integrator. Integrator is the one where output of it has to be the integration of input. That is why V0 is equal to minus 1 upon RC is the constant, and V0 is equal to integration of input basically. So this is about the integrator. Now let us go to the next topic, or the last topic of the applications, which is Opamp as a differentiator. So in this particular case, I have already told you these two will be interchanged, because differentiation and integration are exactly opposite to each other. There in the previous case, the capacitance was at the feedback. Now the capacitance has come across the input. So again the input voltage is given to the inverting terminal, and non-inverting terminal is given to ground. As non-inverting terminal is given to ground, V2 is equal to 0. So now current I1 flows across the capacitance, and the current IF flows across the resistance RF. The current, because of high input impedance, follows this path. If it is following this path, the current I1 is equal to IF. Let us now try to find the value for I1 and IF. Okay, so V1 is equal to V2 is equal to 0. You know it already because of the virtual ground. You also know that I1 is equal to IF. Now let us try to find the answer for what is I1 is equal to. Exactly like the previous case, it is C into D upon dt of the two voltages. Which are the two voltages? The first voltage was like this. This was input voltage. And here across the capacitance, after this point was V1. That is why the current flowing here was I1. This was C. So now I1 is equal to, this is C multiplied by rate of change of, or d upon dt of Vi minus V1. But the value for V1 here is what? It is 0. That is why the answer is C into dVi upon dt. Next, so what is IF is equal to? IF, as usual, this was the voltage V1, here was the resistance RF, and this was the voltage V0. So this was RF, across which was the current IF. So what is IF is equal to? V1 minus V0 divided by RF. So V1 was 0, that is why the answer is minus V0 upon RF. Now we are supposed to equalize the terms. If we are trying to equalize the terms, I'll be getting C into dVi upon dt is equal to minus V0 upon RF. Let us try to take this RF on the other side along with the negative sign. So what is V0 is equal to? V0 is equal to minus R into C. This R is nothing but RF only, because however they are both the same, because R and RF makes no sense here, because there is only one resistance involved. So if this R is taken on the other side, V0 is equal to minus R into C into dVi upon dt. What are we able to understand? The output voltage is nothing but the differentiation of input voltage. In the previous case, V0 or the output voltage was equal to integration of input voltage, but in this particular case, output voltage V0 is equal to differentiation of input voltage. Hence this particular derivation is for differentiator. This is differentiator and the previous one was integrator. Hope the topics are clear. Notes has to be updated.